What is the frequency of the third harmonic on a violin string that is 0.34 meters long, where the wave speed is 299.2 meters per second? Okay, so the first thing you want to do is you actually want to draw this thing. Okay, so remember, both ends fixed. A violin string is, I hope, both ends fixed, right? There's the fundamental. That first harmonic. The second harmonic has a node in the middle. Now, if you saw the first video, of course, you already know that. Ha, ha. All right, sorry, nobody's laughing. So, okay, so then this guy has, so this is 1 football, 2 footballs, and we're gonna have 3 footballs. So sorry about these pictures, right? This is what it would look like if I had skill and talent. So that's really the first step. You always want to do that, right? The next thing is we're gonna set up our L as n lambda over 4. So we got to count how many quarter wavelengths, right? So there's 1, there's 2, there's 3, 4, 5. Looks like there's 6 quarters here, right? 1, 2, 3, 4, 5, 6 quarters, right? So I'm going to go 0.34 is 6 quarter wavelengths. So the wavelength is, I'm going to go 0.34 times 4 divided by 6. And I get that the wavelength is 0.226666 meters, right? All right, we got a page. Luckily, I turned off my speaker. Okay, so that's my wavelength, right? Is 0.2266, right? That's this length here, by the way, right? Just from here to here, okay? Which ends up being just 2/3 of 0.34. So our final thing is we're going to go V as F lambda. Right, so we're going to plug in our velocity. There's our velocity, right? It's the only thing in meters per second. So 299.2 is equal to some frequency we don't know times 0.22666 meters. Sorry, I just can't resist. Okay, so I'm going to go this guy divided by this. So 299.2 divided by that number I just got. Type in a lot of 6s. It's good for you. Right? And when I get that, I get a strangely round answer. I get 1320 hertz. Now, if you think about this, there's an easier way to get this, right? We know that this string, right? This is the same string as in the previous problem. It's this string, right? This string has a frequency of 440 hertz, right? So this string, right? It's going to go 440, 880, 1320, right? This is 1 times, 2 times, 3 times. Remember, the one end fixed, one end open does 135, but the other two go 1 times, 2 times, 3 times, okay? So I could have just done it this way. If I knew that the fundamental was 440, I could say, oh, well, the third harmonic will be 3 times that, right? So that's just a trick.